Hello students, welcome back. This is my second class on the topic states of matter. Last class we were discussing about different forces that exist in between molecules, which are the states in which the molecule or the matter will be present. We have discussed that in our earlier class, that is solid state, liquid state and gaseous state. There are two more states which we are not going to study in this class, but you will study that in higher educations. Okay, first let us start with intermolecular forces. Intermolecular forces. So these may be attractive or repulsive force, okay, between molecules of a substance. This is weak, attractive, or this force may be repulsive also. Attractive or repulsive force between molecules of a substance. So this is not strong force. Intermolecular forces are not strong force. These are weak force. These may be some attractive. Sometimes it will be repulsive in nature. So this occurs in between different molecules in a substance. When the substance alli ಎರಡು atom ಅಥವಾ molecules ಮಧ್ಯ ಇರುವಂತಹ force ನ ಏನಂತ ಕರಿತೀವಿ? Intermolecular forces that will exist in between two different molecules. This is different from electrostatic force of attraction. Electrostatic force andre enu? Electrostatic force exists in between charges. Charge separation idre, for example positive charge matte negative charge idre atom mele alli enagutte bond formation agutte. They will attract each other. Positive charge and negative charge will attract each other. That will be very strong. That attraction is very strong. That is electrostatic attraction. It occurs between charged particles. Here intermolecular forces will not involve charges. It will not involve separate charges. It exists in between molecules and atoms. Okay, so it exists in between intermolecular. So this is different from electrostatic force. So this electrostatic force exists in between charged particles, okay, positively charged particles and negatively charged particles. That force will be very strong. Electrostatic force ಏನಾಗಿರುತ್ತೆ? ತುಂಬಾ ಸ್ಟ್ರಾಂಗ್ ಆಗಿರುತ್ತೆ. ಏನಕ್ಕೆ? ಅಲ್ಲಿ charged particles ಇದೆ. Positive charge ಮತ್ತು negative charge ಇದೆ. They will attract each other strongly. But here intermolecular forces involves molecules or atoms. So this exists between molecules or atoms. This intermolecular forces will exist in between molecules or atoms. This is also called as van der Waals forces. So this intermolecular, remember this, intermolecular forces are also called as van der Waals forces. Okay, so this is some basic introduction about intermolecular forces. These are weak, attractive or repulsive forces which exist between the molecules of a substance. These are different from electrostatic forces. Electrostatic forces will exist in between charges, so they are very strong in nature. This intermolecular force will exist in between molecules or atoms, so it is not so strong. It is a weak force, okay, and it is also called as van der Waals forces. Okay, there are mainly three types of van der Waals forces or this intermolecular forces. So if I say van der Waals force, that is nothing but intermolecular forces only. Okay, there are three types of van der Waals forces. First one is First one is dipole force, dipole force, dipole forces. Second one is dipole induced dipole force, and third one is London forces. First one is dipole. There are three types of intermolecular forces or van der Waals forces of attraction. First one is dipole interaction, second one is dipole induced dipole interaction, and third one is London force. Okay, so first, this London force is also called as dispersion force. Okay, now first let us start with London force. London forces. First one is London force, or it is also called as dispersion force. Dispersion force, London force or dispersion force. Okay, what is this London force or dispersion force? See, before going to this, let us see a term, that is polar and non-polar. What is polar molecule and what is non-polar molecule? In case of non-polar molecules, charge separation will not be there. ಏನಾಗುತ್ತೆ, ಚಾರ್ಜ್ ಸಪರೇಷನ್ ಇರಲ್ಲ ನಾನ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಚಾರ್ಜ್ ಸಪರೇಷನ್ ವಿಲ್ ಬಿ there. That means electron cloud will not be symmetrical. Positive charge will be present. If negative charge is distributed symmetrically around this positive charge, then it will become non-polar. This molecule will become non-polar in nature. Okay, if electron distribution is not symmetrical, ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸುತ್ತಲೂ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಸಿಮೆಟ್ರಿಕ್ ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ, ಈಕ್ವಲ್ ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ, ಚಾರ್ಜ್ ಸಪರೇಟ್ ಆಗಿಲ್ಲ. But in some cases what will be there, positive charge will be there and electron cloud will not be symmetrical around positive charge. Electron cloud ಏನಾಗಿರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಸುತ್ತಲೂ ಸಿಮೆಟ್ರಿಕಲ್ ಆಗಿ ಇರಲ್ಲ. Unsymmetrical distribution of charges will be there. So what this end will get partial positive charge because of the presence of positive charge over this side, and there is no positive charge on this side, and this side gets partial negative charge. There will not be complete separation of charges, but the electron cloud is more here and electron cloud is less on this side. Sorry, there will not be a symmetrical distribution. Symmetrical distribution of electrons will not be there, but in case of this, symmetrical distribution of electrons will be there. Charges are distributed symmetrically, so this symmetrical distribution of charges will give non-polar molecule. Non-polar molecule. This unsymmetrical distribution of charges will give polar molecule. In polar molecule there will be charge separation, but in case of non-polar molecule there is no charge separation. Charge separations iralla in case of non-polar molecules. In case of London force, ಈಗ ನೀವು London force dipole, that is London force dipole interaction, dipole induced dipole force ಅದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ ಅಲ್ವಾ, ಅಲ್ಲಿ ಇದೆರಡು ಟರ್ಮ್ಸ್ ಬರುತ್ತೆ, polar and non-polar. Polar means there will be a charge separation, electron density will not be symmetrical. In case of non-polar, electron density will be symmetrical, distribution of electrons will be symmetrical here. Okay, so first is London forces or dispersion forces. So in case of London force or dispersion force, non-polar molecules will involve. This mainly involves non-polar molecules. Non-polar molecules. Here dipole moment will be induced in non-polar molecules, that is weak dipole moment. London forces are weak forces that will happen in between non-polar molecules due to certain changes in them. Okay, it is a temporary force. London force is a temporary force which occurs in between non-polar molecules and induces dipole in them, temporary dipole in them. Okay, so it is a temporary force. It is a temporary force which exists in between non-polar molecules. This this force is temporary in nature, which exists in between. It's a weak temporary force which exists in between non-polar molecules and induces dipole in them. It will make these molecules polar. Okay, now let us study this by taking an example. Let me consider two non-polar molecules A and B. So this, let this be a non-polar molecule A. I'll write okay, this is symmetrical distribution will be there. And let this be B. A and B. Both are unsymmetrical in nature. Both of these are unsymmetrical in, symmetrical in nature. That means they don't have any dipole moment. They don't have any dipoles in them. Charge separation agilla idaredralli. Okay na? So I'll write it over here. This is a positive charge core. Electron distribution is symmetrical around this positive charge. This is A and this is B. Okay, there is no dipole moment. That means there is no dipole. Charge separation is not there in A and B. Both are non-polar molecules. This is also non-polar. This is also non-polar. There is no dipole. That means both are non-polar in nature. Due to some reasons, by applying magnetic field or electric field, or due to some drastic condition, so what will happen? One of this will become polar. Any one of this, due to some drastic condition, ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ನಾನ್ ಪೋಲಾರ್ ಇರೋದು ಪೋಲಾರ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಐ ಅಪ್ಲೈ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಅಪ್ಲೈ ಮಾಡಿದೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಯಾವ ಚಾರ್ಜ್ ಇರುತ್ತೆ? ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ದಟ್ they will possess a negative charge. So what will happen? That negative charges will push all the electrons. Aden madutte, negative charge and negative charge will repel each other, you know that. So that negative charges will push the electron towards one end. Electrons nalla ಏನು ಮಾಡುತ್ತೆ? one end ಗೆ push ಮಾಡಿಬಿಡುತ್ತೆ. Symmetrical ಆಗಿತ್ತು, now it became unsymmetrical. Charge separation ಆಯಿತು. Okay, so dipole moment will be in this direction towards negative charges. Now this is molecule A which has become polar. I have applied electric field. So now electrons move to one side, and your nucleus which contains positive charge will be present on one side. So this receives partial positive charge and this side receives partial negative charge. There is a separation of dipoles. That means charges will get separated. This is A. Now we have induced a temporary dipole in this. Temporary dipole na ಏನು ಮಾಡಿದ್ವಿ? ಇಂಡ್ಯೂಸ್ ಮಾಡಿದ್ವಿ by applying some electric field or magnetic field. ಯಾವುದೋ ಒಂದು external condition apply ಮಾಡಿ, or due to some changes, what will happen? Dipole will be induced in this molecule. ಈ molecule ಅಲ್ಲಿ charge separation ಆಯಿತು. Electron cloud ಈ ಕಡೆ ಜಾಸ್ತಿ ಬಂತು, ಈ ಕಡೆ ಕಡಿಮೆ ಬಂತು electron clouds. Okay, so ಇದನ್ನ ಈ ತರ ಕೂಡ represent ಮಾಡಬಹುದು ನೀವು. Electron cloud is more like this. You can represent it even like this also, or even like this also. Okay. Now what will happen? This dipole will induce dipole in this molecule, or it will induce polarity in B. B is very nearer to A, so this side contains negative charges. So what will happen? This will attract positive charge in this. A molecule ಈ ಕಡೆ ಸೈಡ್ ಅಲ್ಲಿ ಏನಾಯ್ತು, ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಜಾಸ್ತಿ ಆಯ್ತು. ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಏನ್ ಮಾಡುತ್ತೆ, ಬಿ ನಲ್ಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ನ ಪುಷ್ ಮಾಡುತ್ತೆ. ಲೈಕ್ ಚಾರ್ಜಸ್ ವಿಲ್ ರಿಪೆಲ್, ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ರಿಪೆಲ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ ದಿಸ್. ಓಕೆ, ಸೊ ಇಲ್ಲೂ ಏನಾಯ್ತು, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹತ್ರ ಬಂತು. ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ವಿಲ್ ಮೂವ್ ಅವೇ ಫ್ರಮ್ ದಿಸ್. Negative charges will move away from this. Okay, there will be attractive force between these two, negative charge and positive charge. Initially it was a non-polar molecule. Initial consider ಮಾಡಿದಾಗ ಏನಾಗಿತ್ತು, ಅದು non-polar molecule ಆಗಿತ್ತು. But due to certain condition, polarity was induced in between these two molecules. That may be due to external conditions, some drastic conditions. Polarity will be induced in one molecule. That molecule will induce the polarity in adjacent molecule. ಅದೇನ್ ಮಾಡುತ್ತೆ, adjacent molecule ಅಲ್ಲಿ polarity ನ induce ಮಾಡುತ್ತೆ. How? See, negative polarity induce ಆದಾಗ ಏನಾಯ್ತು, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಈ ಕಡೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಯ್ತು, ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಈ ಕಡೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗುತ್ತೆ. So this negative charges will attract the positive charges in this B. This is B. So they will attract the positive charge in B. So what will happen? And it will push the electrons. Electron will repel each other. So it will push the electron. Okay. So what will happen? That it induces a dipole moment. Here mu is equal to 0 in both mu means dipole moment. Dipole moment is equal to 0 there in non-polar molecules, but in this molecules dipole moment will not be 0. Okay, so there exists some energy between these two, that is interaction energy, that is called as interaction energy. In case of interaction energy, it is nothing but attractive force between these two. Attractive force between these two is interactive energy. This interactive energy IE is proportional to 1 by r power 6. What is IE? Interaction energy, that is energy of interaction which occurs in between these two dipoles. Okay, energy of interaction that occurs in between these two dipoles is called interactive energy or interaction energy or energy of interaction, that is inversely proportional to distance. As the distance increases, as the distance between these two increases, interaction energy will decrease. That is IE. IE represent interaction energy. Interaction energy decreases as the distance between these two increases. It will be around 500 picometer. If distance between A and B is more than 500 picometer, London force will not be applicable. There will be no dispersion force in between them. Okay, so London force is a weak attractive force, weak attractive force, or you can say weak temporary attractive force, you can say like that, which exists in between two non-polar molecules and causes dipole in them, causes a temporary dipole. or due to the formation of temporary dipole in them. Okay, due to the formation of temporary dipole in them, that is nothing but your dispersion or London force. So in London force, that as the distance, since it is a weak force, the weak force ಆಗಿರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, as the distance increases, it cannot withstand very high forces. That means it cannot long up to a very large distance. If the distance is more than 500 picometer, if the distance is more than 500 picometer, what will happen? So this attractive force will die. There will be no attractive force. That means there will be no dispersion force between them. So this is about London force or dispersion force. You should remember, it is a type of intermolecular forces. So it is weak attractive force. Remember this, it is an attractive force which exists in between two non-polar molecules. It is a temporary attractive force, or it is an attractive force which exists in between two non-polar molecules and causes dipole in them due to the formation of temporary dipole in them. That temporary dipole is due to some drastic condition. First you will take, there will be two non-polar molecules. Due to some condition, what will happen? One molecule will induce dipole in it, or dipole will be induced in a molecule. Inducing dipole means charges will separate. There will be a separation of charges in between. Charges ಏನಾಗುತ್ತೆ, separate ಆಗುತ್ತೆ. ಅದರಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಒಂದ್ ಕಡೆ ಬರುತ್ತೆ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇನ್ನೊಂದು ಕಡೆ ಬರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಐ ಅಪ್ಲೈ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ. they want protons, not electrons. They will push the electrons away from it. They will push the electrons away from it. So what will happen? There will be induction of dipole, charge separation. Positive charge one kade bantu, negative charges alla innond kade hoytu. There will be unsymmetrical distribution of electrons. Electrons will be more here compared to here. This side electrons are less, this side electrons are more. So which induces a dipole. Dipole ಏನಾಗುತ್ತೆ, induce ಆಗುತ್ತೆ. Polarity will be induced. Polarity ಅಂದ್ರೆ ಏನು? Charges separate ಆಗುತ್ತೆ. Here charge separation will takes place. This side gets partial negative charge and this side gets partial positive charge. Now I have induced dipole in this molecule. Due to some condition it will change. Okay, so it's a temporary force. This is not a permanent. ಮತ್ತೆ ಅದು ನಾನ್ ಪೋಲಾರ್ ಆಗಬಹುದು ಆ ಮಾಲಿಕ್ಯೂಲ್. ಓಕೆ, ಸೊ ಈಗ ಇದರಲ್ಲಿ ಆಲ್ರೆಡಿ ಡೈಪೋಲ್ ಇಂಡ್ಯೂಸ್ ಆಯಿತು. molecule become polar now. Now this molecule is polar. So ಇದೇನ್ ಮಾಡುತ್ತೆ, ಈ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ ಈ ನಾನ್ ಪೋಲಾರ್ ಬಿ ಇದೆ ಅಲ್ವಾ, ಅಲ್ಲಿ ಪೊಲಾರಿಟಿನ ಇಂಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಹೇಗೆ? ಇಟ್ ಹ್ಯಾಸ್ ಮೋರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆನ್ ದಿಸ್ ಸೈಡ್. ಈ ಕಡೆ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಮೋರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಅಟ್ರಾಕ್ಟ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್. In B, this positive charge will move due to the pull of this electrons. Electrons ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ they will pull this positive charge towards them. ಏನು ಮಾಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಾಪಸ್ ಇಲ್ಲಿ ಎ ನಲ್ಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಿ ನಲ್ಲಿರೋ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ನ ಇಳ್ಕೊಳ್ಳುತ್ತೆ ಅದ್ರ ಕಡೆ, ಡ್ಯೂ ಟು ಇಂಟರಾಕ್ಷನ್. ಓಕೆ, ಸೊ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಮೂವ್ ಟುವರ್ಡ್ಸ್ ರೈಟ್. Because electron repulsion will be there, so electrons will be pushed away. They will move to one side and positive charge will move to another side. So here also induction of polarity will take place. Polarity will be induced here also. Okay, in both the molecules temporary dipole will be induced, charge separation will take place, and there exists an interaction between these two charges that is called interaction energy. That interaction energy is inversely proportional to its distance, r power 6. That means as interaction energy increases, distance between these two molecules decreases. That means as the distance between these two molecules decreases, interaction energy will increase. ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹತ್ರ ಇದ್ದಾಗ ಇಂಟರಾಕ್ಷನ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಮಾಲಿಕ್ಯೂಲ್ಸ್ ದೂರ ಹೋಗ್ತಾ ಹೋದಾಗ ಇಂಟರಾಕ್ಷನ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಆಸ್ ಆರ್ ಡಿಸ್ಟೆನ್ಸ್ R increases, that means distance between these two increases, interaction energy will decrease, that means they are inversely proportional. As the distance increases, interaction energy decreases. As the distance decreases, that is R decreases, interaction energy increases. Okay, so if the distance is more than 500 picometer, distance 500 picometer ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಲಂಡನ್ ಫೋರ್ಸಸ್ ಆಕ್ಟ್ ಆಗಲ್ಲ. This is about London forces. Okay, now in next class let us study about two more forces, two more types of this intermolecular forces. Hope you understood this. This is a new topic for you, so study well. If you have any doubts, you can contact me by any time. Thank you.